function of this thing? Like, I know it's the heart, but like, why are there different colors on it?
Okay, so the big thing about the circulatory system and the heart is that it brings blood with oxygen to your body, which allows it to do all of its basic functions like metabolize and such. So the blood that is red has oxygen in it, because remember, blood has a high iron content, so it oxidizes, making it turn red. And then once it's gone through your body and given its oxygen to the cells through capillaries, it turns blue by the lack of oxygen, and it goes back up through your system through the things called veins, which run parallel to the arteries, back into the heart, and then they run through the heart and the lungs, and they get oxygen in it again, and then it turns red, and it goes and does the whole process all over.
So it starts red, then becomes blue, and then it's red again? Okay. Alright. I guess I got that part. And just, good job, heart. I love it. Get it? It's the heart.
I'd give you the 10
Teacher.
Yeah.
I have another question.
Of course.
I heard there's two kinds of blood cells.
This is true.
Is it orange and yellow?
No.
Is it blue and purple?
No.
They don't. Okay. Well, explain it to me.
Okay, so there's two types of blood cells. There's red blood cells and white blood cells.
Right.
Red blood cells are the most abundant in your blood.
Why?
Because they carry all the stuff. They do everything. They do all the things.
Okay.
So they're abundant. They have the highest like iron content and such. And the white blood cells over here, way bigger. They are fat. And what they do, they're a vital part of your immune system. So they'll just roll around in the blood, and if they see something that's like foreign in the body system, then they will attack it, and they'll kill it. And they are very important for scabbing and for fighting off infection.
What's scabbing?
Scabbing is
Like, is it when you get a scab? Or is it?
Mhm.
Whoa, really?
Mhm.
I was right?
Yeah.
I should get a gold star.
I'll buy some for you.
Yes.
Okay.
Winning.
Okay. So, you know how when you scrape yourself and blood comes out,
Yes.
it immediately gets kind of like a really thin film sort of thing on it?
Yeah.
Okay.
It's weird.
Yeah, those are scabs. So basically what happens is that when you get a cut or a scrape or anything where blood becomes present, the white blood cells will rush to the area and just form little platelets and kind of stack up and make a quick little like bond over your skin so that you'll stop losing blood.
Oh. Really enough of those cells to make up all of our blood?
No, your blood is made up of, I believe, 4 main components. So you have the red blood cells, the white blood cells, platelets, which we talked about, and then something that I forgot, plasma. So,
Is it that stuff from space? That fourth state of matter?
different field. So, I'm going to use blue. So you have red blood cells,
Mm-hmm.
and then you have white blood cells, and then you have, I'm repeating myself, so plasma is this cool thing that makes up 50% of your blood. And what it does is that it just basically is everything that the white blood cells and the platelets and the red blood cells float around in. It is like 90% water. And it is where like different minerals and such will dissolve and like go to different parts of your body. So it's just kind of like this stuff.
It's like a swimming pool that these things just sit in?
No! Here, think about a lava lamp.
A lava lamp?
A lava lamp. You have a lava lamp, and it's a weird conic shape, like that, right? So you have the lava doing its thing, but there's not that much of it, and then you have all this space in between that is just floating around it.
Oh, the gibbly cop.
Not the colored part, the clear part.
Wow.
So this colored part is like your blood cells and your platelets. But this clear part, the water, that's like the plasma.
Oh, okay.
Yeah.
Yeah. Teacher, I'm still confused.
Yes.
Isn't it an atrium where they hold plays and stuff?
No.
Not for this?
No, not for this. Wrong context. So, your heart has 4 chambers. It's like left atrium, right atrium, left ventricle, right ventricle. And so, the ventricles are these things on the bottom, they're the bigger chambers. And then the atria are these chambers up top, and they're a bit smaller. So when your blood comes in, it always comes in through an atrium, and then it goes out through a ventricle. Like no matter what. And so you know how your heart has kind of that offbeat where it's like, so that's because the atrium pumps and it squeezes the blood into the ventricle, and then the ventricle pumps and then it squeezes the blood out of the heart.
Oh,
Yeah.
okay.
Yeah.
All right, teacher.
Yes.
So, what I've learned from this is that the circulatory is a boss and works alone. Don't need no man.
Okay, so that's it. It doesn't work alone. It doesn't work alone. There's a lot of like systems in your body that work together. So recall back to cells, how you have all the little organelles working together, doing their things with the mitochondria, making the food.
It's the powerhouse.
Yes. And so then, you know, all of the R-E-R, and I lost in my analogy. So, three main systems interact with your circulatory system. The respiratory system, the immune system, and the nervous system. Nervous system, we're going to start with that. Features the brain, which is up here. The brain needs oxygen, just like any other organ in the body. So what the brain will do is that it'll tell the heart to pump, and the heart will pump the oxygen all throughout the body, including in the brain. And so with the brain functioning, the heart can function because the brain tells the heart what to do. They're interdependent. Got it? No?
Sorry, I forgot to breathe.
Speaking of, the respiratory system. The respiratory system is about your lungs and breathing. Your lungs are kind of sheltered around your heart and underneath your ribs. And so, what's a major part of the blood?
Oxygen.
Yeah, so what happens is that we
breathe
in
in
air and then it goes down our throat and it gets into the lungs. And so the lungs, you know, have the blood coming in from the heart and it like oxygenates it and it's all cool and then it comes out red and then your cells get air. And that's cool. And the final system that we have is the immune system. And as we mentioned before, this is a
White blood cell.
and the white blood cells, their job is to break apart any sort of invader into the body that is already that has been alerted of, that it's been alerted of.
So it's the bodyguard. Just be proud of me.
So from that terrible pun, the white blood cells, which is a component of your blood, is also part of the immune system, and that is how they are connected. Yeah.
Teacher, I have a question.
Mm-hmm.
If we can breathe air, then how can fish breathe water? They breathe water.
They don't breathe water. They breathe the oxygen in the water because the chemical formula for water is hydrogen and oxygen. So their lungs take oxygen out of the molecule. But that's not relevant to the heart. So fish, their circulatory system is a hell of a lot simpler than humans. So humans have this ridiculous system. Think about when you're running through a science. Yeah, so you start at point A, then you go to point B, then you come back to point A, and then you go a little bit further, and then you come back, and you go a little bit further. So that's what it's like for humans. You have a blood vessel that goes to like somewhere, and then it's out of oxygen. And then it's got to cycle all the way back, and then it gets oxygen again, and then it goes somewhere else. For fish, since they're a lot smaller, it's just like a big old circle. So they have their heart here, and the blood goes, and then it gets all the oxygen out, and then it comes back, and it gets its oxygen again. So it's just one big old circle. Instead of this nonsense of going back and forth and back and forth like humans.
It's a circle.
So, just ask me.
Okay, teacher.
Yes.
Lizards.
Yes.
How they're tiny and how does their blood system work?
Okay. So their blood system works pretty similar to ours because it's a pretty standard plan for things. But lizards are called cold-blooded, which means that they need to stand out in the sun and warm themselves up on rocks to make sure that their body temperature is all right. Cool thing about humans is that our blood pumps and it pumps hot. So that means that those two, and as it's going through, it's making you warm and keeping your body temperature at 97.8 degrees Fahrenheit. Lizards have to stand in the sun to keep themselves warm. And so their circulatory system works the same, but one of their functions is different.
Maybe I'm a lizard. Hey, teacher.
Yes.
Teacher. Can the heart get sick? I feel like every we get sick, but do our heart get sick? Does our heart?
Yeah, hearts can get sick. So here's some pretty common heart diseases, or not common. So, ASD, hole in heart disease. So sometimes when people are born, this wall right here dividing the unoxygenated blood with the oxygenated blood, there's a big old hole in it. And so that means that this blood goes into here, and then this blood goes into here, and it gets all mixed up, and it makes the person like really difficult to live and like hard to do things because the blood just isn't pumping as efficiently as it could be.
Oh, that's
So yeah, it's a birth defect, but it's pretty common to. It's pretty easy to fix. It's risky as any heart surgery, but it is possible to fix. I knew someone that lived to 35 and had no idea that he had a hole in his heart. So it's not deathly. You just need to be aware of it.
And when you turn 35.
Go to a doctor. Yeah.
Okay. Well, that's a birth defect, but that's like not getting sick.
That's true. So there is coronary artery disease. Coronary artery disease is, there's a big fad to not eat a bunch of fatty foods like McDonald's and whatever else.
It's so good.
Yeah. So when you eat that stuff, you get a lot of plaque buildup in your arteries, and so like, say this is your vein, and it's all good, blood's flowing through, everything's happy, and then you eat a cheeseburger, and then you eat a cheeseburger. And you get a little buildup right here. Doesn't really do anything. But then, you eat another one, and you get more buildup. And then you eat another one, and another one, and another one, and eventually, what used to be this really wide pathway for your blood is now a lot skinnier. And your heart has to pump way harder than it had to before just to get your blood going. So that can cause a bunch of strokes in your brain because the blood just can't get there anymore, and it can also just make moving and everything a lot more difficult.
I guess I'm going to have to cut back on the cheeseburgers.
Yeah.
But still, that's kind of something that
Teacher,
you can prevent.
Mhm.
I hear that a lot of people have, like, I don't know, I think I have a big heart.
Yeah. That's not good. If your heart is bigger than your fist, then it's disproportionate to your body and it just messes up with the pumping. And sometimes the walls in our hearts get too thick, and it's very similar to the coronary artery disease. So what used to be like a thin wall right here is now like that thick. And this is like twice as thick. And it just makes everything a lot harder to move around and to pump because there's just so much more resistance against like the actual action of pumping.
Man, I guess I don't want a big heart.
You want a proportionate heart.
Proportionate hearts!
Yeah. Oh, okay. So, and that disease where everything gets thicker is cardiomyopathy.
But bam! Teacher!
Mm-hmm.
This has been fun and all, but this isn't actually fun.
Yeah. I have some fun facts. Would that make it better? I'm going to tell you anyway. So, if you take all the arteries, the capillaries, and the veins in an adult body and you lay them out end to end, it winds up being about 60,000 miles. I know, right? They're just everywhere. Everywhere. All right. Fun fact 2. The heart can still beat when you take it out of the body.
So that's why they always have those mind depictions where he just rips the heart out of someone and it's like, get him, get him, get him, get him, get him.
Yes.
For the gods!
Yes. Do you know why? No. Okay, so when the heart beats, it generates its own electricity, and so once you take it out of the body, it can still beat and generate the electricity. It's kind of like a residual effect. Like, when you take a tail off of a lizard and it just kind of squiggles? It's like that. But they're a vital organ.
Oh, that's always fun.
Okay, fact number 3. So, however long ago, this Greek dude in the time of philosophy was like, the heart does this! And everyone was like, yeah, let's believe him. And he was dead wrong. He thought we were like fish. He is stupid.
So it was a circle.
Yeah.
I thought.
Okay, and then the 4th and final fact for stabbing people is if you come out of a very serious relationship or a very dramatic and emotional time, your heart can physically hurt.
The feels!
Yeah, like that. So your brain tells your heart that it should hurt because you've always been told that your heart should hurt when you're upset. And so if it gets too out of proportion and ridiculous, then it could actually cause some serious damage.
I'm dying! I'm dying.
So if you're very sad after a breakup, please talk to someone because your heart shouldn't actually hurt that bad. Like this.
Teacher, I need help. I have a respiratory test tomorrow.
Yeah, you do. What do you need help with?
I don't know anything.
Oh, that's not good.
What does the respiratory system do?
Okay, so the respiratory system I'm holding this one. The respiratory system is it's your lungs and your esophagus and your trachea and all of that right here. It allows for the gas exchange in your body, so you know how you inhale oxygen and you exhale CO2?
Yes.
Yes, okay. So that happens all right here. All of it. And it brings the oxygen into your blood and allows for oxygen to go to your cells and such.
Okay, but teacher, what is this epiglottis?
Epiglottis?
Yes.
Okay, so that's like, think of it as a door, and it's right there. And so when you swallow food, it closes so that no excess saliva or air goes down with your food.
Mm. What are other things that are part of the respiratory system?
Okay, so you have the lungs, the vital part, the diaphragm, which is right underneath your lungs, and it pushes and pulls to expand to give your lungs more room to have air. And then you have the bronchus, which are the little tubes inside the lungs that put the air into it. And then you have the trachea, which is a part of your throat. And there's the nasal cavity, and then your mouth, and that's where the air goes in when you breathe. And then you have also, where did it go? Oh, your vocal cords. Your vocal cords are in your throat, and they're a part of the respiratory system because while you're talking, you're exhaling air, and your vocal cords are vibrating the air in your throat to make the sounds, and that's how we speak.
Oh, okay. So because like our vocal cords take in the air, it shakes our little voice box to produce sounds.
Mm-hmm.
Okay. Pause.
Let's figure out what the
Teacher.
Mm-hmm.
Okay, we talked about the vocal cords, but you didn't really explain what this was. What was it?
Okay, so the larynx is the thing that houses the vocal cords, and it also directs where the air goes, or where the things that go down your throat goes.
Okay.
So, and then the trachea is, so once the air goes down the throat and to the larynx, then it goes to the trachea, and then the trachea directs it to the bronchus.
Ah.
Or bronchi, I think that's a plural. So yeah, if you're in the hospital and you're having difficulty breathing, then the doctors will cut your throat and stab the trachea to put a tube in it so that you can breathe.
Okay.
Fun fact. Kind of disturbing, but yeah, so that's it. What are you doing?
I'm drawing a person.
Mm-hmm.
I should be studying, shouldn't I?
Yeah.
Oh.
Yeah. Okay, so what does the respiratory system do?
It helps us. We breathe in air and oxygen is exchanged throughout our body.
How does breathing work?
Don't know.
Okay, so when you breathe, you take in air and it goes to your lungs. Well, to take in the air, the muscles around your ribcage contract, and that way it makes the muscles around your ribcage contract, and then your diaphragm flattens out because usually it's that kind of shape, but when you breathe in, it flattens out so that there's a whole bunch of space in your chest cavity for the air to go. And so the difference in pressure between inside your body and outside your body draws the air from the outside to the inside. Then when you exhale, the muscles around your ribcage relax, and then your diaphragm returns to its dome shape, and it pushes the air out of your body. And that's how you breathe.
Teacher.
Yes.
What's on the test tomorrow besides the respiratory system?
Okay, so you're going to have all the systems, but you should focus on the circulatory, digestive, and nervous since they relate to the respiratory system. So the circulatory system and the respiratory system interact because the respiratory system provides the oxygen to put into the blood to give to the circulatory system. The digestive system, they both use the throat. And also, the digestive system interacts with the respiratory system because the digestive system provides energy for all the systems in the body to work, especially the respiratory, because that's what we're talking about right now, and the nervous system. The nervous system is what tells the lungs when to contract and when to expand, to take in the air and such, and that's how they interact.
Okay. So without the nervous system, I'd be able to breathe right now or even function?
Yep.
Okay.
The nervous system is like the boss of everyone. Tells them what to do. What are you doing?
Teacher,
Yes?
is the respiratory system so boring?
Yes, it is.
Can you give me an example?
Okay. Elephants are cool, right?
Yeah.
Yeah. Okay. So elephant's respiratory system is pretty similar to ours. The main difference, though, is that it doesn't have a pleural cavity.
What's a pleural cavity?
A pleural cavity is the space between the lungs and the body walls. So, like, for us, there's a space between our ribs and our lungs. And that way, they can expand and such, and it's all cool. For elephants, they don't have this space. So if you were to push, like, any sort of pressure against the elephant's chest, it would make it very difficult for them to breathe, and they would not be happy at all.
Oh, that's pretty interesting.
Yeah. Are you okay?
Yeah, I just have asthma.
Oh, did you know that's a respiratory disease?
Yes. I did.
Okay, cool. You know what causes it?
Nope.
Okay, so asthma is when your bronchioles, which are the little extensions of the bronchi, when they contract and they have spasms, and it makes it very difficult for air to get to your lungs. Exercise, that's one. When they have one of these attacks, if they can't get it treated with an inhaler soon, then they could, they could die. Oh, yeah, I'm sorry. That got really negative. Another respiratory disease is cystic fibrosis. Cystic fibrosis is a genetic disease where a thick mucus builds up in your lungs. And because of this mucus, lots of microorganisms thrive in the lungs. So people with CF are very, very susceptible to respiratory infections like pneumonia. When people have cystic fibrosis, the main treatment for it is to just prevent the mucus buildup. So to pneumonia. Pneumonia happens usually after the flu. It's a pretty treatable disease, except, unless you're very young or very old. Let's see. It's just an infection of your lungs. It's usually one lung, but it can be two lungs, or it could just be little, quarters of your lungs. But it's treatable, and it goes away in 2 to 3 weeks.
Okay, well, earlier you told me about the elephants. That's cool and all, but that's probably still not that interesting to me.
Yeah. I have some fun facts.
Yay!
Yay! Okay. So, did you know that when you exhale, you're losing a lot of the water in your body?
No.
Yeah. So when it's cold outside and you breathe and then you see all that fog and stuff in front of you? That's just the air. It's just the water in your breath condensing to form a little fog.
Oh.
Yeah. Okay. And then also, did you know that the lungs are the only organs of your body that will float in water?
Really? Why?
Because the lungs are basically balloons. They have a lot of air in them and they're very hollow. And as opposed to a heart that's just solid muscle, which is pretty heavy, it'll just float on the water. Okay, and asthma used to be treated as a psychological issue. Doctors way back when thought that maybe people were just nervous all the time, and that's where they had the asthma attacks, which is so very wrong. And final fact: the world record for holding your breath is 22 minutes. The person who did that was from Denmark, and he achieved that record by doing lung packing, which is a very weird process where people take a breath, hold it, take another breath, hold it, but it's very dangerous. Don't do it unless you're a professional. The general average is about 30 to 60 seconds. And that concludes our lesson.
Yay!